Thank you. So as you said, my name is Mike West. You can get all the vital details up there. It's really just an exercise to see how many times I can type Mike West on the same page. The slides are actually online right now. I'm using SpeakerDeck because SpeakerDeck is awesome, and my computer decided, hey, I'm not going to connect to the laptop or to the projector. So if you want to follow along with the slides, you can grab them right now. I'd suggest you just, hop over there, take a look at the slides, and look at them afterwards as well. Because what I really want to do today is give you an introduction to a kind of wide field of things that can go wrong on your site. Specifically, I want to talk about content injection attacks. Content injection is probably the most pervasive problem on the web from a security perspective. Absolutely every website will have a content injection hole of one sort or another at one time or another. It's really difficult to do things correctly. We all make mistakes. Google makes mistakes. And if Google is making mistakes with teams that are actually dedicated to security, reviewing all the code, you can be damn sure that you guys are going to make mistakes as well. Does anyone actually have a full-time security person on their team? I am actually shocked. There are people with their hands up. Usually, everyone sits there in stunned silence saying, what? Pay someone to work on security? That's crazy. Generally speaking, security is generally pushed to the end. We usually worry about security when it's too late, once we've found a hole in the site, as opposed to worrying about it up front. I think that should probably change. But let's talk about content injection. Content injection happens when you either, one mechanism of content injection is poor escaping. So you get some content from a user, you escape it incorrectly, and then write it out to the page. What you see here is a relatively exhaustive list of the contexts in which code can be output to a site. So you have a color in a style tag. You have a username directly inside of an HTML element. You have a URL that's inside of an attribute. You have a user ID that's written directly into script. And you have some debug information put into a comment. For each of these contexts, the rules are different. For example, if I have 2 dashes inside of a comment, that actually closes the comment. 2 dashes inside of a p tag, of course, have absolutely no effect other than writing out 2 dashes to the page. You need to be very careful about the ways that you escape data when you write it out to the page. You need to know the context in which you're writing out data, and you need to make sure that you escape the information correctly for that context. It's honestly trivial to do. All you have to do is be perfect. You simply have to know all of the rules and apply them perfectly every time you write out any data. Data that's coming from you, data that's reflected from the DOM, data that's coming from get parameters. Every single time, you have to be perfect. It's kind of difficult to do. Why is content injection important? Well, to understand that, you have to understand the concept of an origin. An origin is a pairing of a scheme, a host, and a port. So HTTP, example.com, 80, or HTTPS, google.com, 443. Those are 2 distinct origins, and the browser can guarantee that those origins should never have direct access to information from the other origin. Example.com must never be able to access, for instance, cookies from google.com, or local storage, or any of a number of other HTML5 storage mechanisms. You're kind of already familiar with this concept with regard to JavaScript, because JavaScript has a number of ways in which it can be A, injected into a page, and B, read interesting data like cookies, and then exfiltrate that data out to a third party. Of course, solving content injection on the web is simple, right? We just turn off JavaScript, and we're done. Easy. Just tell all your users to go into content settings, turn off JavaScript on every web page, and they will never have another content injection problem again. Sure, someone might write some content onto your page, but it's just text. It won't actually execute. So how could anything dangerous happen? I am here to talk about dangerous things. There's an excellent paper, and most of the things that I'm going to talk about today come from Mario and come from this paper and a number of others that he's published. I don't do attack research. I am not the right guy for that. But I want to talk about it a little bit just to give you some context so that then at the end of this talk, I can talk about the things that I think are important. Defense. I can show you how to harden your website against these kinds of attacks and also against all the other kinds of cross-site scripting attacks out there. I actually really recommend that you take a look at this paper. It's kind of an academic paper, but it's really easy to read, and it walks through a lot of the concepts that I'll be talking about here. And again, all the slides are online. You'll see the URL at the end again. What I'm not going to talk about, although I find it incredibly interesting, are timing attacks. Timing attacks, I would love to talk about them, but they require JavaScript. And because of that, I cannot talk about them at CSSconf. But I can show you this white paper. This was presented, I think, in June of this year. And it is absolutely stunning what you can do simply by looking at how the browser renders things. This guy gives you an excellent mechanism by which you can detect whether or not a user has visited a page. The history attacks, we've basically shut those down via JavaScript. In other words, you can't directly read the style of a visited link. However, if you're very clever and you read the paper, it's absolutely incredible. He can actually read individual pixels across origin through an iframe. It's the most amazing thing that I've seen in the last couple of months. I really highly recommend you read it, but that's not our topic for today. What we want to talk about today are content injection attacks. And for a content injection attack to be successful, it needs 3 components. There needs to be an injection, and I guarantee you that there are injections on your page. I'm not even going to talk about it because it happens everywhere. It's really difficult to avoid. Then it needs execution. And for JavaScript, execution is quite clear. The code executes or it doesn't. What I propose is that execution should be, you should conceptually include things like the application of style. If style executes on your page, then I'll show you some problems that can pop up. And then there needs to be some sort of advantage for the attacker. In the most cases, the advantage for the attacker is exfiltration of interesting information from your website. This might be a CSRF token. We'll talk about those in a moment. It might be a password. It might be the user's bank account information. Anytime the attacker can get secret information from a page and exfiltrate it to a third-party server, to a server that they control, then they've gained some sort of advantage over you. We'll talk about how all of these can happen within the context of CSS. First, I'll talk about the obvious stuff. Defacement, phishing, anything along these lines. If someone can inject style into your page, then by definition, they can change the way that your page looks. And to a certain extent, they can change the way your page behaves. In the worst case, or in the most simple case, they can simply hide everything on your page and change the background of your page to something that you would not like to have as your home page. These are really trivial attacks. There's nothing really interesting to say about them other than if someone can inject style into your page, they can change the way your page looks and at best embarrass you, at worst trick users into clicking on things that they shouldn't click on. So if you have a hole that allows someone to inject style, they can almost certainly inject HTML as well. And if they can inject HTML, they could inject a form, they could inject a link, and bring a user to a page that the user isn't expecting to go to. A style injection will help them with that. It'll help them take whatever they can inject and make it look like it's supposed to be on your page and make it very enticing for a user to click on. So if your bank account suddenly said, hey, here's 5 free euro, then you're probably going to click on that button because, hey, 5 free euro, that's awesome. Of course my bank is going to give that to me. Because of that, anytime that an attacker can inject style into a page, it's actually more dangerous than you might think, just in terms of defacement. But again, that's not particularly interesting because it's kind of obvious. What would be more interesting is if we could take some sort of secret information on the page, information that isn't actually visible to the user, and exfiltrate it somehow. So for example, every time you have a form on a website that posts somewhere and does something in the back end, you generally want to make sure that you are the only one that can post to that URL. One way to do that is to have a CSRF token, which basically says you give each user a one-time pad. So here's a secret. And then they use that secret when they submit the form. Because, of course, you can submit forms from anywhere. Forms and posts are not particularly hard to trick a user into making. This is why you want to make sure that you give the user a secret, and then the user uses that secret to execute something on the back end. It'd be really useful if an attacker could find some way to pull that secret and give it over to themselves, as opposed to only having access to it within the context of your page. How could we go about doing this? It's an input element. And we need to use CSS in some way to apply style to that element only when it meets certain requirements. One mechanism that we could use, of course, is an attribute selector. Attribute selectors are great. They allow us to apply styles only when the attribute matches a certain value. So in the worst case, you can brute force the value of an element. or of an attribute on an element by injecting a whole lot of style, or more appropriately, by injecting a link to a style sheet such that the style sheet loads, has a whole lot of style information, and the Csrf token will be matched if it matches a certain value. So this shows you how you would do it if the Csrf token was binary. Most Csrf tokens are, in fact, not binary. They use a lot more characters, which means brute forcing isn't particularly fast. It's actually quite slow. But once we have this, once we are able to match a value, and of course, you don't have to use equals. You can use starts with. You can use ends with. It'd be really nice if there was a regex of some sort, but there isn't. I'm hoping that comes up at some point. I'm really excited about web components. Let's see where we go with that. I think that so once you're able to inject script or inject style, and that style can match certain elements on the page, we still have to have some mechanism by which we give that information to a third party. Happily, CSS makes this quite trivial by giving us the ability to load resources from any URL on the web. That's kind of nice, right? So I'm going to set a background image on this Csrf token of evil.com and then csrf equals 0. And I'm going to repeat this for every single brute force attack that I'm making. So value equals 0, value equals 1. At some point, I will match the token, and I will exfiltrate that token out to a third-party server. The third party now has the ability to, if you can phish the user in some way, which is really trivial, then you'll know a Csrf token, you'll hope the user hasn't used it yet, and you'll be able to submit something that actually has effect, as opposed to something that doesn't. This was talked about way, way back in 2009. I think the presentation was called The Sexy Assassin, which is a terrible name for an it's just a terrible name in general. I think they'd probably be embarrassed about it now. But the attack is something like this. I type yay. And then only using CSS, they're able to, using looking at the front, looking at the back, and then combining those selectors, they're able to actually detect what the value is across origins, which is actually kind of cool. What this proves is that simply with CSS, you're able to read the value of elements on a page, and you're able to exfiltrate that information. Now, this is relatively slow. We'll look at some things later on that will speed it up, and that will actually make it more practical for an attack, as opposed to this brute force mechanism, which is kind of impractical. The point here is simply that execution and exfiltration are not only possible, but quite plausible within the context of CSS. I'd recommend that you take a look at this. If you do, I think, question source, then you see the PHP stuff. This is relatively old, so the code's not awesome, but it's certainly worth looking through just to see how it works. So, continuing. What if we wanted to steal a get parameter? Instead of looking at something on the page, what if we wanted to look at the URL of the document? Unfortunately, this only works in Firefox. There's a bug here that you can star if you want it to work in WebKit too. I think that would be interesting. But there is an amazing selector called mozDocument. And mozDocument allows you to use a regex to look at the name of the document, to look at the actual URL, and then do some sort of styling on the page based upon that URL. This is really, really useful for like user scripts. People that are injecting some sort of code into a page, they only want to have one style sheet, but they want to do slightly different things on different pages. It would also give you the ability to kind of a poor man's ability to scope style to a certain section of your page. So you include the same style sheet on every page in your site, but you have certain styles that apply to your home page, certain styles that apply to your about page, something along those lines. There are some use cases for it, but it gives us this really interesting ability to set up regular expressions. And if we have regular expressions, we can do something much more efficient than brute forcing. We can actually look at each character individually and determine what those characters are and what the position of the characters are. So let's go, whoops, what is that? How do I get back? This isn't my computer. Help. Where'd we go? No, really. You think it's funny, but it's not. Where's my Chrome? There we go. Look at that. So let's go. Oh, give me a break. You'd think working on Chrome, I would actually know how to use Chrome. Unfortunately, not the case. I just write code. I don't actually know anything about how this works. So we're on a website. we'll grab a PHP session ID, which is relatively common. It's much more common than it should be. Basically, every templating language will have a session ID of some sort because some people turn off cookies. So if we get a session ID, nothing actually happened that I saw. Nothing happened on this page, so of course I'm perfectly safe. Unfortunately, that's not the case. So if we go into the network and then reload the page, oh, haha, I need Firefox. Is there Firefox on this machine? Is it? Oh, that's awesome. Where'd my Firefox go? Oh, look at that. Oh, this is going to be great. Oh, I need my net. So it'd be really nice if Firebug stayed open when I navigated between origins. So I'm in net. Let's reload. And I'm filtered to CSS. There we go. So what we see here is that it's actually able to read each character and exfiltrate both the character and the position to a third-party server. So all evil.com has to do is look at its logs, and it now has a session ID for a user. If the user has been to evil.com before, it also has a cookie. So it's able to not only identify the user, but also get a session ID, which means I can just go back to this website, use that as my session ID, and for all intents and purposes, I am this user. It's a kind of interesting attack vector. Again, it only works in Firefox, but in Germany, a lot of people use Firefox, so it's kind of an interesting thing to do here. There are other browsers. That's all I'm saying. So we've looked at CSRF tokens. We've looked at the get string. It'd be really nice, actually, if we could just steal any arbitrary attribute on a page. That'd be kind of useful, right? Because a lot of pages, especially in this brave new world of single-page applications, are starting to store things in attributes that are really quite interesting for us. So templates, the sort of data binding stuff that's going on with Angular and a variety of other languages, start storing much more interesting things in attributes than they used to. And because of that, it gives us actually a really interesting opportunity to start taking more useful information than we were able to get to before. Now this, I don't have any demo code for. Instead, I don't have any code to show you in the presentation. I'm just going to show you a quick demo. So this is a proof of concept. And what this is going to do is steal some information on these links. So let's say that we're in a popular bulletin board program that doesn't use post for its admin, but instead just says delete user and then has a secret attached to that, so as a get parameter, which is actually kind of common. And now I'm back over here. Why is that? My antivirus has expired. What's up with that? It's craziness. Don't have an antivirus. This is a Mac. So if I reload this page, you'll see something interesting happen. Right? There's an animation going on at the top, and you see some red stuff pop up and then go away. That's kind of interesting. Red stuff popping up and going away. What could that possibly be? If we look at the net tag, then we'll see actually that what's happening is that requests are somehow being made. And these requests are exporting or exfiltrating information about something that's contained in this link. How could this possibly be happening? The animation is used to measure the width of an object. Why is that important? Well, it's important if we construct a specially crafted font that only has width for one character. So T has width, but no other character has width. This allows me to measure the width of an element with an animation that says, go down to the right size and then come back. I measure the width by looking for the presence of a scroll bar. I can detect the scroll bar because WebKit, for amazing reasons, has a lot of scroll bar properties. And in this case, WebKit's scroll bar track piece vertical increment only loads when the scroll bar appears. Most scroll bar attributes actually load at page load, which isn't very useful for data extrication. But if we look only for those specific properties that only load data or only load resources when the scroll bar pops up, then we can measure the width of an element and then tell an external server that this element was this wide at some point, which means something. In this case, it means that it contains an S or it contains a T. This gives us the information that we would then need to more efficiently brute force a password or more efficiently brute force a token of some sort. You can actually make this much more efficient by using contextual alternatives in WAF. Contextual alternatives are amazing. they're really very useful. So if you look at this, I need to go back into full screen mode. If you look at this, you'll see that the text on the page is, "Dear Mom, keep your plates clean. This time I will cook for us this Sunday at 3. So it's a very beautiful letter from a child to a parent. And we see that it's been made even more beautiful by the presence of a WAF font that says, every time you see the 4 characters DEAR, replace them with a picture of a deer, because a picture of a deer is lovable and happy and makes everyone just thrilled to get a letter like this. What it also does is allow us to change the width of particular strings of characters. What this allows us to do is to build a font that can be used to attack people. You've heard of dictionary attacks. We can build a dictionary font. So all the most common passwords can each have, the first password can be 1 pixel, the second password can be 2 pixels, the next password can be 4 pixels, and so on. We can use this information, and then using, I'm sorry, I missed something. The thing that's important that I forgot to say is that you bring the data out from the attribute by using a pseudo element. So you do like a after, and then in the after, you use content, and content is attrib of href. So you pull the attribute, you put it into the DOM somewhere where it can be measured, and then you measure it. You saw that it was like a 5-second animation. You don't have to wait 5 seconds. You can actually do it much more quickly. And this allows you to do it even more quickly still, because instead of evaluating each character individually, and instead of having defined 26 different occurrences on a page, you can simply have 1 occurrence, and then look for the particular word in order to determine which of these things matches. And I'm really excited about the potential for media queries on elements, because that's going to make something like this even more valuable, because you'll actually be able to determine exactly how wide an element is with pixel precision. With an animation, you actually have to do a timing attack. You have to look at the start of the page load, so you send some sort of information to the server, and then you animate, and then based upon how long it took, you can start guessing at which password it might have been. It's less useful than it would be if we were able to pixel perfectly measure each element on the page using a media query. If we can start doing that, then I'm actually quite excited about the potential for not only web components, but also attackers, because that's going to be fun. So anyway, the point here is that by using a couple of different properties of CSS, you can exfiltrate data that you really didn't expect to be able to exfiltrate. A dictionary font of about 100,000 entries is less than a meg. So users, especially if you look at websites these days, if you look at like the iPhone 5S website, it's like 17 or 18 meg for the entire site, which is kind of ridiculous. And in that context, downloading a meg for a font is not even going to notice. It's kind of cool. Again, I would recommend that you look at those 2 papers that I pointed out at the beginning. They go into a lot more detail about the practical application of these sorts of attacks. What I want to do here is just give you a flavor for what can go on. And what I'd like to do now is tell you how you can actually defend yourself against these sorts of attacks. The main problem that we talked about, or the main problem that I expressed, is that the browser executes all the code that it sees. And it executes all that code in the context of your origin, which means in the case of CSS that it has DOM access. It can read things from the DOM and can exfiltrate data to third parties. Does anyone know what this picture is? This painting. OK, a couple of people. This painting is Odysseus and the Sirens. I think it's a really interesting story, and I think it's a metaphor that's going to be very applicable in a moment. So the Sirens, they sing beautifully. So beautifully, in fact, that it drives men to the point of madness, especially sailors. Sailors are kind of crazy anyway, but with sirens, they're even more crazy. And because of that, they just want to be near the music. They want to hear more music, and they just throw themselves overboard in order to get closer to the music to hear more of it. Throwing yourself overboard is not a great way to steer a ship. So ships usually then crash into the island where the sirens live, and I guess, I don't know, they eat people, who knows. Odysseus is an egomaniac, and he is amazingly hubristic. Because of this, he wants to be the only living person to have heard the song of the sirens and survived. He wants to hear this beautiful music, but he doesn't want to throw himself overboard. That's counterproductive in a deep way. So what does he do? He tells his men to tie him to the mast. They tie his hands behind his back. They bind his legs tightly, which means he can't get away. He can't do anything. Then he instructs his men to put beeswax in their ears and to wrap things around their head as kind of earphones or earplugs of some sort. Then he tells his men, OK, row past the island where the sirens are. Don't go to the island. Just keep rowing. Ignore anything you see, and just get me past this island. The Sirens come. They sing their beautiful songs. Odysseus is driven to the brink of madness, but he doesn't throw himself overboard. He can't. He's bound from doing so. And his men, they don't care about the Sirens because they've got stuff in their ears. They're humming to themselves, who knows. They row him past the island. He's able to listen to this beautiful music, but he's able to survive while doing so because he's given his men explicit instructions, and then he's prevented them from doing things counter to these instructions. It'd be really nice if we had a mechanism to tell the browser to only load the things that we want it to load, to only load our style and not style from somewhere else. We can do this. Can do this with something called content security policy. Content security policy is a whitelisting mechanism that allows us to say, script from this source, style from this source, but from no other sources, please. I want only the things that I specifically have told you that I trust. Here's some information about my trust. Now execute that within the context of a page. I edit the spec along with Adam Barth from Google and Dan Beditz from Mozilla. They are both very smart. They tell me what to type, and I type it. It works out. It's a beautiful relationship. This is the content security policy for a really high-value site, mikewest.org. You may have heard of it. It's really amazing. Content security policy is best delivered as an HTTP header. The name of the header is content-security-policy. And then you see a lot of semicolon-delimited directives. Each of these directives controls a certain type of content on a page. We start by setting a default source of none, so we say no content should load, just don't load anything. And then we slowly open that up. We say, OK, you can load style from here, you can load frames from here, you can load script from here. This gives you the very granular ability to say, origin 1 is something that I trust. That's my content delivery network. Please load script from there. If, however, you see script from somewhere else, don't load it. In fact, throw some sort of interesting error like this. Refuse to execute inline script because it violates the following content security directive. Those are excellent errors to see. This is a more or less exhaustive list of the directives that exist in Content Security Policy 1.0. Content Security Policy 1.0 is available now in Chrome as an unprefixed header. It's available now in Firefox, also as an unprefixed header. I expect it'll be available in Safari 7 as an unprefixed header because I landed that before we forked. And what's really interesting here is the last directive, report URI. Report URI gives you a mechanism of actually seeing attacks that are going on. So instead of just showing it to the developer right at their workstation, you can actually post a message to your server saying, hey, I tried to load some information. I failed miserably. Perhaps you should look at that. Perhaps you should take a look at this area and see if maybe there's an injection that you've missed. This is what the report looks like. It gives you some context. If it comes from JavaScript, we'll do our best to give you like a line number and a column. Inline script. This is the last thing I'll talk about. Inline script is the biggest problem on the web. In this case, I would say inline style is the biggest problem on the web. What do we do with that? It doesn't really come from an origin, right? It's embedded directly in the page. What I would suggest is that you externalize this information. You put it into an external JavaScript file. You do some DOM manipulation in order to set up your event handlers. Or in the case of CSS, you simply load the style from somewhere else. Then it has an explicit origin. We're able to very, in a granular way, determine whether or not we should load it. And the browser can do something interesting based on that information. This is the only thing I want you to remember from the talk. This is the most important thing I will show you today. It's an article written by an amazingly handsome man. And this article will give you all the practical detail that you need in order to take content security policy and start actually applying it to your pages. It'll give you all the details about all the stuff that's in 1.0. I need to update it for 1.1. That hasn't quite happened yet. 1.1 is still kind of in specification. So there's a lot of new stuff. There's a lot of really interesting stuff. Please at least bookmark this article and tell somebody else about it, even if you don't read it yourself. I would really like to hear from you guys what sorts of things you see applications for with regard to content security policy and any problems that you see actually implementing on your sites. And with that, I would say thank you.